In this video, we are going to see the selection of subsets of data using .loc method and .iloc method. Now, what does subsets of data mean? So, we know what a data frame is, right? Pandas data frame is a two-dimensional table with rows and columns. So, probably selecting a few rows and few columns would be a subset of the entire data set or the data frame. So, maybe you are selecting all the rows and few columns, or all the columns, one row, or few rows. So anyways, all this combination of selecting data from a given data frame is called selecting subsets of data. And to do that, we have two methods, that is .loc and .iloc. .location, .integer location. .loc method is one which takes labels as parameters, and .iloc method takes integer values as parameters. And the syntax of both of these are very simple, and if you have any confusion, always fall back to this simple syntaxes which says df.loc. df is the data frame, df.loc, and within the square brackets, not the round braces, it's rows comma columns. And here again df.iloc, rows and columns. These rows and columns for .loc, these are going to be labels. The parameters are going to be labels. For .iloc, the parameters are going to be integers. And also these parameters, let's say for .loc, I said they are going to be labels. There could be single label. You can use a list of labels, or you can use slice of labels. All this we are going to see in the coming examples in a short while. But similarly for .iloc, you are going to see the parameters to be a single integer. It could be a single integer, it could be a list of integers, or it could be a slice of integers. So this is brief overview, and let's get started with some examples. Let's load some data set. Let's say df is equal to pd dot read underscore csv and test.csv. Let's load this data frame and check the first 5 rows. All right, okay, let's do a little cleanup. Let's set the index of player to this data frame, and let's remove this unnamed column and unnamed 11 column. So let me check the columns. df.columns, this is a property which gives the column. So these two columns, I don't think they are of any relevance, so let's remove these two columns. Okay, and how do you remove? df.pop, you can remove this column by the name unnamed. Okay, and then let's verify this if it is removed or not. All right, so there is nothing by the name unnamed 0. Similarly, what we'll do is let's clean up unnamed 11. Okay, all right, so it is removed. And let's set the index player, because the index here 0 1 2 3 4 is kind of redundant. So what we'll do is df dot set underscore index. We are going to set index for the data frame, so it is df dot set underscore index. And what is it? It is the player, and we have to assign it to the data frame and then check if it is done correctly and properly. So there you go, we are here. We just cleaned up a little bit for the data frame. Now let's get started. Now what we'll do is let's start with a few rows and a few columns. Okay, maybe I'm interested in rows to be like mm, you know Sachin Tendulkar. I'm just randomly picking a few rows. Okay, and then a few columns. Then these would be like 100, 50, Then what is it? I have to use this df.loc, right? The syntax is df.loc rows comma columns within the square bracket. So df.loc within the square bracket rows comma cols calls columns. So I'm interested in these two rows of Sachin Tendulkar and Cook, and columns 100, 50 and 0. Their respective hundreds, how many hundreds they made, 100, how many 50s they made, and how many times they got out on 0. So let's run this. There you go. You got the data frame with the respective values or the respective rows and columns. So this is a combination of rows and columns. Now let's say I want to only check Sachin Tendulkar. Okay, so the row here is simply Sachin Tendulkar, SR Tendulkar, and I want to keep the same columns the same. Now I'm going to use df.loc and I'm going to say again rows comma cols and see what happens. Okay, what did it just happen? df.loc rows, okay, this is rows, or let's keep this as a row. Okay, yeah. All right, so what did what happened here? Here it we did not get a data frame, we got a data series instead. So there is a note here that I'm going to play, going to write. If either of rows or columns have a single value, that is single row or single column, then the output is a data series rather than data frame. So here the row is a single value, columns are many but it is single value, therefore the output is a series, not a data frame. But instead what you can do is you can convert this by a simple trick that we have seen in previous videos too. Make it a list and run it, you are going to get a data frame. Alright, again, to just validate this note what we have written, to validate it, okay, to validate it, let's try and see a single column and multiple rows. Let's take another row here. Let's run this. See, now why did I get data frame? Because I have put this in square brackets. So if I remove the square brackets, it turns out to be a series. All right, so this is simple distinction or the simple observation that we have seen. Now we have what we have seen using .loc. We have seen combination of rows and columns and combination of single row, multiple columns, and multiple rows, single column. So these kind of combinations we have seen, and we have used a trick of using square brackets. Right now, um, what if I want single row or all the columns? All right, single row, all the columns, and then all rows and single column. So single row, let's say I'm interested in Sachin Tendulkar and I want all the columns. Now what I'll do is Now what I will do is I'll say df dot loc. So I want single row, and what is that row? This is the row. Sorry, let's put this in single quotes. This is the row, and I'm putting comma, and I want all the columns. All the columns. I'll simply use colon, and let's see what happens. There you go. You got Sachin Tendulkar and all the columns. These are all the columns, right? But the thing is, this is a single row. For single row, the output is a data series. So what you will do is just put a square brackets here and run it again, and you'll see that this is a data frame. Now what did you get? You got Sachin Tendulkar with all the columns, all the necessary columns. You got it. This is what a single row, all the columns is. Now all rows and single column. Similarly, what will happen is df.loc all rows. That's why I'm putting colon, comma, and single column. Let's say I'm looking for AVE average. Okay, let's run this and see what happens. Now again I got a series instead of data frame. Why did I get a series? Because here we are using a single column. Now if you used, instead of this, if I just used the trick that we learned using the square brackets and run it, you get a data frame, all the players and their respective averages. Okay, now you can use multiple columns, right? Maybe you can use high score also, HS. All right, and see what happens. You get the same thing, right? So a more readable version of this would be like what? COLS is equal to AVE, comma, HS, and then you'll say df.loc, comma, COLS. Both are the same. Both are the same. These two and these two lines of code and this are the same. Only thing is this is more readable, and this might be little confusing because you are using two square brackets, right? It's a list. This is a list. You have to see this as a list. Anyways, moving on, what we have seen is slicing now, right? Slicing. Now you can use another way, slice of rows and slice of columns. Slice of rows and slice of columns. What am I inferring here? Let's say df dot loc, then I'm going to say from SR Tendulkar. See again, all the parameters are labels here. If you observe, SR Tendulkar to probably Rahul Dravid. Okay, comma. So this is all the rows, and I'm using slice, comma. I'm going to use probably runs, highest score, and average, right? That would be fine. So I'll say runs and slice it till average. All right, and let's run this and see, there you go. I got, when I use this is slicing operation on the rows, and this is slicing operation on the columns. All right, and again there is another thing that I wanted to show you. If I say, if I use colon 2, okay, if I use colon 2, rows jump by 2. What happens is rows jump by 2. So it starts with Sachin Tendulkar, it goes to Jack Callis. Okay, after that there is no jump or values present, so only Sachin Tendulkar and Jack Callis are displayed. Okay, and similarly, if you do for let's I'm just removing this, and if you do for the columns too, so the columns will jump by 2. So runs and average are displayed. There is no highest score. All right. Now let me show you another operation here. So let's say you want to show all the columns, right? This shows all the columns. Now what I'll do is I'll use colon 2 and see what happens. What happens is it starts with the first column, it jumps by 2. So here column jumps by 2. Okay, column jumps by 2. Just to make sure you understand, I'm just using this dot head. Okay, so it starts with span. Okay, it goes to innings. So span is there, innings is there. After innings it jumps by 2, right? 1 2, so it goes and gives the runs again, AVE, and again 50. So these are different ways. When you're using colon here in the row side, it jumps by this number. If you're using in the column side, it jumps by this number. But when you're trying to use from everything from starting to end, you can jump by a certain number by using double colon and the number. So these are different variations, and you can extract the subsets of data. Now after this you can just say like df and maybe like 1. You can save it to a new data frame, and then after that you can, okay, let me save this to df.1. So df.1 is like what, sorry, df underscore 1 is like what, this is a data frame with these values, right? Maybe what I can do is df underscore 1 dot 2 underscore csv. Maybe I can save it to csv file by the name df underscore 1 dot csv. All right, and it gets saved, and I can download it, I can use it, I can load it, and so on. All right, so there you go. Here you can download it and so on. So the point is like this: using .loc, you have seen selection of multiple rows, multiple columns, single row, multiple columns, single column, multiple rows, all kinds of combinations. You have used it to see to use the parameters as a single label, list of labels, and slice of labels. Now let's see what dot iloc does. Now we have seen what dot iloc is, right? The syntax of which is same as that of loc. Okay, now let's make a small distinction here, and let's say df syntax is df dot iloc rows commas columns. Okay, now as I told, I in iloc stands for integer. So what you will do is rows, you pick up some integers, let's say 0 1 2. Columns, maybe also pick up some integers. Okay, 0 1 2. Now okay, okay, or maybe use 0 2 4 random numbers. Then you'll say df dot iloc, then you'll say rows comma cols, and see what happens. So you got 0th index row, 1 index row, and 2 index row, and columns 0, 2, and 4. Okay, so 0, 2, 0, 2, 4. Span, innings, and runs. That's what you got. So it is similar, analogous to .loc. Only thing is, the parameters here you're using could be single integer, list of integers, or slice of integers. Now, if you use, let's take this, and uh, if you use a single integer, okay, let's say 0, and run this, what will happen is you'll get a series. To make this data frame, what you need to do is apply square brackets, our trick, and then it becomes a data frame. So whenever there is a single row or a single column, be it a label, be it an integer, the output is a series, and you use a trick of using square brackets to make it a data frame. Okay, now let's see the slicing operations in these two also. So let's say df dot iloc, and we'll say all the rows, and only the only probably the first and last column. Let's see what happens. Okay, first and the last column. Okay, uh, okay, you don't need square brackets for this, and the first and the last columns are 0 and -1. Oh, okay, from 0 to -1. So okay, first and last columns are this one. First and last columns are this one. I think this we are going to get span and zeros. Okay, this is first and last columns. Yeah, but if you want df.iloc rows, sorry, all the rows and all the columns, you can simply use this. And if you want only rows from 0, 1, 2, 2 to 5, let's say, columns from 2 to 5, you will get what? 2, 3, 4, 5, and this is excluded, so 2, 3, 4. So this is, as I said, analogous to .loc, and this is how you can get all these things. So you can, maybe you are interested in using this data frame, you can save it to a variable, and then save it to a Excel format or CSV format, any format that you wish to. So to summarize quickly, what we have seen is selection of subset of data using .loc and .iloc, and the parameters for .loc are labels, and parameters for .iloc, that is integer allocation method, are integers, and the parameters for .loc could be single label, list of labels, slice of labels that we have seen, and for .iloc we have seen the list, the parameters to be single integer, list of integers, and slice of integers. And this is a syntax that you always need to fall back, and which are df.loc rows comma columns, df.iloc rows comma columns.